all measurements here, then cut it finally, and then fold along these lines, and then make the box. Right? So that is the idea basically. So development of surface means basically what we need to produce something. For that, what we need to do. That is called development of surface. So means basically if you want to draw one cylindrical surface. What do you do basically? You how many surfaces are there for the cylinder? Say for example closed cylinder. How many surfaces are there?
Surface plane or one curve?
Total three surfaces. So this is one. This the same at the bottom, identical surface and a curved surface. Right? So therefore, if I want to produce this one, keeping that in mind that I have to produce it, so what I do? That means I have to produce this cylinder. That is not available. I have to produce. So I have designed it. Now I have to manufacture. Clear? I have to manufacture. So to manufacture that, what I need to do? Say for example, this box was not there. What was there initially? Initially, what was there? Sheet was there. So from that sheet, it is produced, right? So what we needed? Basically, we needed to design it, right? We needed to design it. That means after that, it was pasted here at this point. They were folded here, right? At different locations, they were folded. Finally, it is a box. So initially, you had a sheet, right? You have seen, in the sweet shops, right? You have seen some boxes. They are initially in a form of a sheet. They fold it and then give you the sweets, right? So actually, the seeds are available, but they need to fold to make the box, right? But what is actually required is that we will design in such a way that there will be minimum loss. Right? So before we have to design, otherwise what will happen? Just without understanding what will be the final shape, we will cut and then we will see that it is wasted. So that should not be, right? So what is done is before means manufacture, we have to first design, then develop the surface and then produce this. So this is the surface from 2D. This is in 2D and finally we get the 3D. Just by folding at different locations, right? Similarly for this, if I have a surface like this cylindrical surface, so I know that what I have to do, I have to make a welding, right? I have to weld. Say for example, if it is say metal one, right? I will weld. So welding means initially it was cut, then I will weld. So what I will do basically, I will unfold. Initially means in the final form it is folded, but actually it is unfolded like this. So therefore I know this length. So this is say L or H. And this is R or D. So what will be the unfolded length? Can you tell? After I unfold, how much will be the length? Means when you unfold, when you cut it and then unfold, what will be the total length? Pi d. This will be pi d. So it is the diameter d, but the length will be that perimeter. So it will be pi d. Right? So therefore, I will draw a length which is pi d. Pi d means about 3 times of d. Little more than that, 3.1415. So it is like this. So if it is d, then 3 times a little more than that. So that is this. And what is the height? H. Height is h. right? Next, what we do for this top and the bottom surface, we can draw some circle anywhere. Anywhere. You can draw it here, you can draw it here, anywhere. Right? So according to your choice, you can draw it here. One here. What is the length? D. So it will be D and then circle. Or you can cut it from different plate and simply weld, because you have to weld. Now what you do, basically you roll it and make the shape of this cylindrical surface. Curved surface complete. This is the plane surface, the lower one is the plane surface and the side is the curved surface. So you will basically produce this from this, because this is 2D and this is 3D. Right? So this is called the development of surface. That means you want to produce this, so this is developed first, then you produce this. Right? So this way you can do all the surface development. Okay. Now, for example, if I want to take, if I want to design simply a cone. Conical surface, only say curved surface. By this time you know that what is the flat surface, plane surface, that is easy to do. That is simply a circular surface, plane surface like this. That will simply a plane surface like this. Okay. Next, what? You have to make a cone. Make a cone like this. So it will be placed on the top of this. So I have to do this. This is easy to do. There is no development needed, right, for this. What development we have to do for this? So how to do it? That means as if you have produced like this. You have cut it, right? You cut it here. Somewhere you cut. Right? Another thing is important is that here for this, that means this will be placed, this edge will be placed together. These two edges will be placed together. So before cut, before joining, they were separate. Now once joined, they will have the same edge. They will have the same edge. Okay. That means this edge and this edge, they will basically coincide. So their numberings will be same. Right? They will be basically having the same number. Okay, is it okay? That means so that when you join this one with the other, this edge and this edge, they are before joining they are separate, but after you join they will become one. Right? Like this. So their reference will be same. So that when, because say for example, when you manufacture, this is okay. You know, you have the idea. But when you are say the who is actually going to produce it, they will not know that you have to join these two edges. So if you give the same number or give the same reference numbering, then they will be easily understanding that it can be joined. These two edges can be joined. So that is the idea. That means to give the number, same number at these edges, it means that they will be joined. Okay? They will be joined. Otherwise, there will be no information that either they will be joined or not, whether they will be joined or not. So giving the same number is meaning that they will be joined like that. So what will be the developed surface like this? Can you tell? What will be the 2D version of this? What will be the 2D version of this? This is 3D. What will be the 2D version of this? After you cut and unfold, unwrap it. Sheet. What will be the shape? What will be the length? Say for example, this is D. I told. This is D, isn't it? So what will be this length? Can you tell?
ID.
What will be this length?
ID.
5, right? So this will be 5. This will be pi d. Okay? So one length is pi d, another length is this one. So this is a L. This is a L. The lateral length is say L, inclined length L. Okay. Now, when you basically unwrap, what it will make? Basically, can you tell? Do you have any problem? Means it will be unfolded. Now, one thing is that, one idea is that, you see, from this vertex, all the points on this periphery are equidistant, isn't it? Is it clear? That means from this point, say this is say vertex D, all the points on this edge they are equidistant. This is L, this is also L, this is also L, this is also L. They are all same. Right? So when you unwrap, therefore, that will be maintained. You are not distorting. Simply you are either making either folding, you are folding or unfolding. You are not distorting. Okay? You are not deforming. So therefore, this length will be maintained even if after unwrapping. Clear or not? Clear? Therefore, what we will do is we will draw a line first, the same as this one. Same as this one. Next, I know that from this point, this is a V. From this point, all points on this will be equidistant. So that is only one geometry which has this feature is a circle. Right? Which has this feature is a circle. That means from a particular point, if all points are equidistant, then it is a curve, which is a circle. Isn't it? Clear or not? Is it clear? So what is the radius of the circle? L. So this is L. Now therefore I will draw a circle. Circle like this. It will be a circle. But where it will go? How much? What is the length?
Pi d.
Length is
Pi d.
pi d. So this length will be also pi d. Right? This will be pi d, isn't it? This length is pi d. But can you measure the curve length? Can you measure curve length? The length of a curve can you measure? Do you have any device to measure the length of a curve? You have? Means have we given any such device which can measure the length of a curve in your list? Instrument? Don't see. Whether is it there or not? Curve length? So how to measure, how to do this? That means how to get a pi d. This is pi d. This length is pi d. So that is pi d. perimeter pi d. Small d. So how to produce a length which is pi d? So for example, this is S. This is S. So if this is S and this is L, then we know that S is equal to L theta or theta. S is equal to r theta simply. The length of an arc is equal to radius multiplied by the angle extended by that arc into the in the center. That is the meaning. And the condition is that theta is in radian. Theta is in radian, right? That is simple from your trigonometry, means coordinate geometry, trigonometry. So this is like, you see, therefore what we know is S, what we know is L. These two are known. S is known, this is pi d, and L is known, this is this. So we do not know theta, because where to end, we have started here, where to end we do not know. So we will determine theta first. So what is that? Theta is equal to S by L. What is S?
Pi d.
Here S is equal to pi d. So therefore we will write pi d by, therefore we know therefore theta. We have determined what is theta. So now we can get that, whatever be the value of theta. So if I give some value of L and D, then you can determine theta, right? Accordingly we will determine. So for